Hello student, welcome back. This is Bharat Kumar from Mechanical Engineering Department. So student, today we are going to discuss about the ideal gases. So without a wasting of time, let's start today's topic. Definitions. A hypothetical gas which obeys the Boyle's law exactly at all temperature and pressures, and which has an internal energy that depends only upon the temperature. Means ideal gas is totally obey the Boyle's law. If we talking about real gases, it is a gas that does not behave an ideal gas due to interaction between gas molecules. Means real gas is not obey the Boyle's law. A real gas is also known as a non-ideal gas because the behavior of real gas is only approximated by the ideal gas law. Boyle's law. Robert Boyle and Robert Hooke used a jet tube to measure the volume of a sample of a gas at different pressures. Student, here we can see in the diagram, there is a jet tube. Added a mercury compresses a gas and increase the pressure. They observed an inverse relationship between volume and pressure. Hence, an increase in one causes a decrease in other. Means here they find an inverse relationship between a volume and pressure. So student, here we can see in the graph also, here there is a volume versus pressure graph where we can see the pressure increase and volume is decrease. Okay, Mr. Boyle used a jet tube, okay, used to mercury, okay, and they find a relation between pressure and volume where pressure increase, volume decrease. Here we can see in the diagram where pressure will increase gradually, at that time volume will decrease. Pressure of a gas inversely proportional to its volume. Here pressure of gas is inversely proportional to its volume where temperature is constant and amount of gas. Graph pressure versus volume is represent as a curve, okay, and graph P versus 1 by V is represent as a straight line. As a P increase, so V will be decrease by the same factor. Here P is a pressure and V is a volume. Okay, so here we finally get the equation P into V is equal to constant. If we talking about for state 1 and state 2, so this relation become P1 V1 is equal to P2 V2. As the volume of gas sample is decreased, gas molecules collide with surrounding surfaces more frequently, resulting in the greater pressure. If pressure increase, volume will be decrease. So it is nothing but the concept of Boyle's law. Let's discuss about Charles' law. The volume of a fixed amount of gas at a constant pressure increases linearly with increasing temperature in Kelvin. Means pressure will be constant. The volume of a gas increases with increasing temperature. So we can find the relation V by T is equal to constant. If we talking about a state 1 and state 2, so relation will become V1 by T1 is equal to V2 by T2. Now student, here we can see in the diagram, okay, so the temperature will increase, volume will also increase where the pressure remain constant. If we talking about Charles' law, so pressure remain constant, temperature and volume both will be increase. Here we can see in the diagram, okay, temperature gradually increase, volume also increase and pressure remain constant. If the lines are extrapolated back to volume of 0, they all show the same temperature. Minus 273.15 degrees centigrade is equal to 0 Kelvin, called absolute 0. The extrapolated lines cannot be measured experimentally because all gases condense into liquid before minus 273.15 degree centigrade is reached. So student, here we can understand from this diagram about the Charles law. Okay, if we move a balloon from an ice water bath to a boiling water bath, its volume expands as gas particles within the balloon moves faster and collectively occupy more spaces. Means there is a one balloon put in a ice water and moved in boiling water, so its volume will be expand. When the temperature of a gas sample increases, the gas particle move faster. Collisions with the wall are more frequent. The force exerted with each collision is greater. The only way for the pressure to remain constant is for the gas to occupy larger volume so that collision becomes less frequent and occur over a larger area. Now student, let's discuss about Avogadro's law. Volume directly proportional to the number of gas molecules, where V by N is equal to constant. Okay, here pressure and temperature both are constant. More gas molecules is equal to larger volume. Count number of gas molecules by moles. Equal volume of gases contain equal number of molecules. Here we can see in the graph there is a volume versus number of molecules graph. Here we can see the amount of gas is increases where volume is also increases. So Avogadro law represent the amount of gas and volume both are increases when temperature and pressure remain constant. When the amount of gas in a sample increases as a constant temperature and pressure, its volume increases in direct proportion to because greater number of particles fill more space. The volume of gas sample increases linearly with the number of moles of gas in the sample. Student, let's discuss about the relationship between this ideal gases law. Here we just discussed about the PV is equal to nRT. Okay, it directly represent the constant N and T which represent the Boyle's law. Then after constant N and P is represent the Charles law, and last but not the least constant P and T is represent the Avogadro's law. Here we can see in the diagram also with the equations where V is proportional to 1 by P represent Boyle's law, V is proportional to T represent Charles law, V is proportional to N represent the Avogadro's law. Student, kindly attempt this mind twisted question and find a following link in a description box. So student, here we just finished today's session. In upcoming session we will discuss about a more interesting topic. Till keep learning, keep growing. Thank you.